Okay, so I'll give you a second just to dig out your notes, copy this down. These really make me happy. I love identities. Like this, I'm like, oh, can't wait to solve it. This unit, it really depends on your brain. If you are more left brain, this will be an easier unit. If you're really right brain, this will be a challenge. So it's really just how your brain is wired. As a mathematician, we look at this and go, how? How are those the same thing? How does it work that all that crap on the left is equal to tan plus cotan? So first thing I do is I put that line because that stops my brain from doing that equal sign. If that doesn't work for you, you don't like that, don't use it. Now I want you to have this hint box beside you in the notes, have it right beside you. These are just hints. I can't tell you this is always going to work. It's just general things we go through. The first thing we like to do is change everything to sine and cos, because then we're dealing with 2 functions as opposed to 6 functions. We like to look for sine squared plus cos squared, because we know that reduces down to 1. We simplify fractions. We try to factor. We work on the more complicated side. But again, you can't just follow these step by step and think it's magically going to work all the time. First thing is pick a side. So to you, which looks like the more complicated side, left or right? Okay, so let's go to the left. What do you want to do? Well, the first hint is usually change to sine and cos, so let's do that. Cosecant squared, look on your card, is equal to what? Right, so we talked about the formulas on the front, we can put the squareds in. The formulas on the back, we cannot take them out. So cosecant is equal to 1 over sine, so that means cosecant squared is equal to 1 squared over sine squared, and what's 1 squared? 1. So cosecant is equal to 1 over sine squared. Okay, so that's just a direct substitution from our card. Then I'm going to do the same with secant. So secant is equal to 1 over cos. So secant squared is equal to 1 squared over cos squared, which equals 1 over cos squared. Now just a couple hints to my tree-loving, paper-saving students. If you are a tree lover who hates to waste paper and you write really, really tiny, don't be someone who puts fractions on one line. So lots of people will just write fractions like this because they're trying to save paper. That's going to mess you up here because we're going to end up with a fraction over a fraction, and then it's hard to see when it's on one line. Is it the top? Is it the bottom? So for identities only, just waste some paper. Write them as fractions on 2 lines. Now I like to put that big dividing line just so my brain can see what was on the top originally, what was on the bottom. Because now we're going to do the same thing on the bottom. I'm going to change the cosecant to 1 over sine. And I'm going to change the secant to 1 over cos. Okay, you can see now why I put that big dividing line just to keep straight top and bottom. A common mistake with identities is people will start putting signs in, and I mean plus or minuses. Cosecant times secant is a multiplication, so down here don't put a plus sign in, don't put a negative, it's still a multiplication. Some people's brains can see multiplication better when you bracket these, so if when you substitute you want to bracket it to see you're multiplying, that's fine. So on the top I have an addition, the bottom I have a multiplication. Which one would you like to do first? Addition. Okay, so I'm going to put that big dividing line, leaving a couple spaces. And again, if your brain is like, wow, there's a lot going on here, then just cover the bottom. So let's just not look at it right now. Let's just look at the top. How do we add fractions? Common denominator. So what's common between sine squared and cos squared? Sine squared, cos squared. I'm just going to literally plunk those together. So the top fraction of the first one's going to be sine squared times cos squared. And the second fraction is going to be sine squared plus cos squared. And again, if your brain's still like, then just cover the bottom, don't look at it, we're just looking at the top. Okay, how do I go from a sine squared to a sine squared cos squared? What did I multiply by? Okay, and I don't usually write this, I'm just going to show you for this one what's happening, is we're multiplying by cos squared. Okay, so if we multiply the bottom by cos squared, we have to multiply the top times cos squared. So 1 times cos squared, cos squared. Okay, so what I put in green here, you don't need to write. I'm just showing for the visual people what we're doing. Same thing with the second fraction. We say, okay, what did I do to cos squared to get a sine squared cos squared? I multiplied by sine squared. So 1 times sine squared, sine squared. want you to pause here, and you're going to grab your red pen in a second because we're going to put a note. You need to resist the urge to cancel. And that's going to be really hard because we have lectured you on canceling since grade 5. Cancel, cancel, cancel. And your brain's going to see this and go, oh, well, I can cancel these cosquareds and I can cancel these sine squareds, and look at that. But what's going to happen if I cancel these cosquareds? I'm going right back up to this step. And if I cancel the sine squareds here, I'm going right back here. So write yourself a note, resist the urge to cancel when you're adding fractions. Resist the urge to cancel. If you do, no big deal. You're just back up with the step above, and then you're just going to have to redo it. But again, your brain's going to want to cancel because we've lectured you to cancel, cancel, cancel. I'm going to finish off the top, then I'll come back to the bottom. So I'm going to leave a lot of space and put that big dividing line in again. And now I'm just going to finish off the top. So once we have common denominator, what do we do? How? Okay, so keep the bottom. And the top, we're just going to smush it together, so it becomes cos squared plus sine squared. Oh my God, that makes us really, really happy. Look at that, look at that, look at that. Look at that. What do you see there? That's so exciting. So I'm going to keep that big dividing line. Do you see how these are paper wasters? I'm going to take out cos squared plus sine squared, and I'm going to put in 1. I know, these are paper wasters. So some people will do one step on the top, one step on the bottom, the second step on the top, the second on the bottom. That's fine. I like to do all of the top and finish it, and now I'm going to go back to the bottom. Just matters how your brain works. I'm going to switch colors so that you can see which was on the bottom and which was on the top. And so we're going all the way back to here. This is a multiplication. Do I need common denominator? No. So how do I multiply two fractions? Top times top, bottom times bottom. So 1 times 1, sine times cos, can I reduce anything? Can I cancel anything? Can I simplify anything? Is there anything more I can do with 1 over sine cos? Nope, so I'm just going to keep it all the way down to where I have the numerator. Okay, so just repeating a few things. This is why I put that big dividing line, so that it's really clear what was on the top, what was on the bottom. Some people like to change color so they can clearly see what was what. If you're not visual and can do it without, great. So I've simplified the top, I have simplified the bottom. Now I'm down to a division of fractions. How do we divide fractions? Flip the reciprocal is the same as flip, so take the reciprocal of the denominator, the second fraction. So this first one I'm leaving exactly the way it is. 1 over sine squared cos squared. Putting a multiplication sign. And I'm just flipping the bottom one. So sine cos divided by 1. Top times top, bottom times bottom. So 1 times sine times cos, sine cos. And on the bottom, sine squared cos squared times 1. Ooh, does the bottom equal 1? You tell me. No, why not? There's no addition. So just because you've seen a sine squared and a cos squared doesn't mean you can cancel it to be 1. It has to be addition. Can we do anything with this? So we can cancel here because we're multiplying everything. So I can cancel the sine on the top with the squared on the bottom. And I can cancel the cos on the top with the cos squared on the bottom. So this is identical to xy over x squared y squared. Okay, so just like in grade 9 when we simplified this, we're doing the exact same thing. So what is left on the top if I cancel the sine and a cos? 1. And what's left on the bottom if I cancel out the squareds? Whew, that was okay. So let's go through our steps. Change everything to sine and cos. We did that. Look for sine squared plus cos squared. We did that. Simplify all fractions. What that means to simplify is that you're down to one numerator, one denominator. So these steps up here wasn't simplified yet because we had a bunch of numerators, denominators. So is this as far as we can go with our fractions? Yes, one numerator, one denominator. Try to factor. Okay, can I factor anything? So usually to factor, we need something to be squared. If there's no square, it's probably not factorable. Try working on the side that's more complicated. We did that. Okay, now we're down to, oh, okay, we're stuck, so we're going to work on the other side. Okay, so let's go to our right-hand side. What would you like to do on the right-hand side? Okay, so cotan is? Okay, thoughts? So again, if you're not sure, take a look at that hint box, follow down, so change sine and cos, check. Look for sine squared plus cos squared. Nope. What's the third hint? Simplify the fractions. How do we add fractions? Common denominator. What's the common denominator between sine and cos? Sine cos. How did we go from a sine to a sine cos? What did we multiply by? Cos. So cos times cos, cos squared. And if you want to put in the green like I had on this side, if you want to do it here, that's fine if your brain sees it that way. How do we go from a cos to a sine cos? What do we multiply by? Sine, so sine times sine, sine squared. And real left brain people can probably already see what's going to happen in a step or two. Okay, keep the bottom. Smush the top together. Oh my God, this makes us so happy. Why do we love cos squared plus sine squared? What do you see? And now we just need to write a conclusion. You have two choices. What are the two choices? It's not CAD. Did she tell you what that stands for? It's in Latin. It's quota errata demonstrata, which means it has been proven. If you don't like that, what's the other choice? It's not equal, so be careful. What's the symbol in between? It's 3 equal signs, and that means it has been proven to equal. So the left-hand side has been proven to equal the right-hand side. You have one of these, but not both. Your choice. Are you ready? Because there's going to be a dance of joy. Why am I the only one dancing here? Oh, I will wait. I will wait until you are all dancing. Let's go, let's go! Chair dance. You guys suck. You just suck. You totally suck today. Questions so far on the 6? This is a medium to hard one. So at this point, you may look at that and go, wow, there's no way I would have gotten that on my own. That's okay, because this is what you're going to be practicing over the next couple of days. Number 7. see how. How does tan squared divided by secant plus 1, how is that equal to cos? Where did the coses come from? It is kind of math magic. Pick a side, any side, left or right? Left. Why did you pick the left? Because there's more stuff to play with. That's exactly right. If we had picked the left, or sorry, the right, what would we have done with it? So change the sign and cos, combine the fractions, sine squared plus cos squared, factor, right? If you'd gone to this side, you would have been stuck because there's not a lot to do. So left is a really good choice. What would you like to change? Tan squared into? That is one of our quotient identities, by the way. Now, at this point, you might want to not look at the bottom and just finish off the top. It's totally up to you. I'm going to go to the bottom. So you want secant into 1 over cos. Okay, going to the numerator. Change sine and cos. Done. Look for sine squared plus cos squared. Okay? It actually has to be sine squared plus cos squared. You can't just say, oh, well, they're both there. This whole thing equals 1. Okay, so you can't make up identities. Can we factor anything? Okay, there's no terms beside just the one top and bottom. Or combine all fractions. So is there anything we can do with the top at this point? No, so I'm just going to copy it down for the next step. Okay, what about the bottom? We can definitely add, okay? Don't forget this is 1 over little imaginary 1. Now for non-visual people, identities can be absolutely, well, I was going to say give you a headache, but I don't know what that would be. So sometimes for non-visual, if you box and then box, it's a little bit helpful to see where the pieces are going and what's on the top and what's on the bottom. Cos and 1, what's the common denominator? Cos. So the first fraction is going to be over cos, and the second fraction is going to be over cos. Okay, the first fraction. How do we go from cos to cos? What do we multiply by? 1. So 1 times 1 is 1 on the top. So the first fraction doesn't change. 1 on the bottom turned to cos. What do we multiply by? Cos. So 1 on the top becomes cos. What are you going to resist the urge to do right now? Cancel. And your brain's going to want to look at this and go, oh, well, I can cancel that and make it 1. And if you did that, what happens? Well, you're right back up here, right? So resist the urge when you're adding. Okay, I'm going to keep the numerator because we haven't touched it yet. I'm going to put in that big dividing line. And what do I do with my 2 fractions on the bottom? So how do I finish off the adding? How is my question. Perfect, so keep the bottom, smush the top together. Okay, now I'm into this division, so the top divided by the bottom. Again, sometimes it's helpful to circle or highlight the bottom so you see what's going to switch here. The top fraction I'm keeping exactly the way it is. Putting my multiplication sign. And the bottom I'm going to flip. Take a look at this fraction on the right of this part here. Can I cancel these coses? Why not? Cos on the top, cos on the bottom? Well, why can't I do that? Because there's a plus. And if you've been looking at my cute little puppy and kitten pictures up there, look at the bottom puppy one. You can't cancel half of a binomial. I can't take this cos because it's joined to the 1. So if you do that, that puppy's going to die. Just saying. Okay, can't cancel here. What about these coses? So across the fractions. Why? because they're not being added to anything. So the cos on the top can go with the squared on the bottom. Okay, so the top, what do I have left? Sine squared. And the bottom? And I agree, but I'm not going to multiply it out, and I'm going to tell you why in a second. I'm just going to smush it together, cos times 1 plus cos. Okay, so it's not wrong if you multiply it, but I'll tell you why I didn't in a second. So change everything to sine and cos. Check. Did we find any sine squareds plus cos squareds? No, I would have squealed, you would have heard me. Simplify all fractions. Well, that's what we just did. Try to factor. Okay, if I had multiplied out the bottom, I would have now had to turn around and factor it. So I would have had cos plus cos squared. I would have factored out a common factor. That's why I didn't multiply here, because one of our steps is factoring. So if you multiply, you're just going to turn around and factor it. So can't factor. Okay, work on this side is more complicated. Done that. Okay, now I'm stuck. Now what? Okay, let's go to the other side. We talked about this at the beginning of the question. What can we do on this side? Okay, so that doesn't mean you're stuck. It just means you need to do what I call compare. You need to compare, this is what I want, this is what I have. What has to go? So what is on the left right now that is not on the right? The sine squared. I need to somehow get rid of the sine squared. So I call that comparing. Compare your sides. What's there that's not on the other? I need a sine squared out. So take a look at your card. What can I swap it for that maybe involves cos? Oh, so I can put 1 minus cos squared on the top. And keeping the bottom exactly the way it is. So we weren't stuck yet on the left. You just need to do what I call compare. You're going to compare the two sides. What do I need to get rid of? I need to get rid of a sine squared. The only way to do that is to change it into 1 minus cos squared. Okay, so I'm kind of getting there. I've got the 1 minus. I've got the cos on the bottom. What do I still need to get out of here? So what's on the left that's not on the right? The 1 plus cos on the bottom and the squared on the top. I want you to highlight, circle, put some glitter glue around 1 minus cos squared. I have glitter up there if you need it. And I'm just going to come and make a note on the left because we're not going to use the left-hand side anyway. I want you to go back to grade 9 in your head and tell me about this kind of factoring. That's the offer, agree, disagree. What do we call that kind of factoring? Difference of squares. Well, what if I switch them around? What if I gave you 1 minus x squared? One plus x and 1 minus x. Well, what if I gave you 1 minus cos squared theta? So this is a difference of squares. It will always be a difference of squares. So it's going to be 1 and 1. Plus and minus, cos and cos. What if we had the other equation, which is the 1 minus sine squared? Is that factorable? The 1 minus sine squared. Yes, so those two are always going to be difference of squares. 1 minus cos squared, 1 minus sine squared will always factor like this. Okay, so let's swap that back in. 1 minus cos squared, I want to be 1 plus cos. And 1 minus cos. And the bottom I haven't done anything with yet, so I'm going to keep our cos and our 1 plus cos. And what did that difference of squares allow us to do right now? Okay, what can I cancel? So why can I cancel here and up a few steps you told me I couldn't cancel? Because we're canceling the entire binomial. So I can't cancel just a cos, but I can cancel the entire thing. So on the top, I have a 1 minus cos. And on the bottom, cos. What do you see? that not immensely satisfying? Identities make me happy. Like, oh, that feels so good. I picked this example specifically because until you see this as a difference of squares, you would never be able to solve this. So you want to make sure when you're looking at the homework questions, you're always looking back at your notes, and anytime you see 1 minus cos squared or 1 minus sine squared, you can always factor it. Dance of joy, are you ready? Dance of joys. Dance of joys. Thank you, Noah. Thank you, Noah. Maddie, come on, you're a dancer. Come on. You guys seriously suck today. You suck. Number 8. I can always tell on the final exam when people get the identity because they start doing a little dance of joy. Because let me tell you, on the exam, it feels really good when you get the identity. You cannot play that song. I could sing it for you, but you probably don't want that to happen. Again, I've picked these examples very specifically because they're kind of ones when you look at you couldn't solve on your own unless you've seen one. But I cannot show you every single identity in the world. Well, I could if you stay with me 24/7 for the next 500 years. We could do every question in the world. But I'm just giving you ones that are going to look like the homework questions. What's different about this one that we haven't seen before? The powers of 4. Okay, change everything to sine and cos. Looks like it's done. Look for sine squared plus cos squared. Can we just pretend those are squareds? It doesn't work that way. It'd be great if it did, but it's not going to work that way. Simplify all fractions. Okay, try to factor. Oh, factoring. What kind of factoring is this? This is a difference of squares. It's just like before because 4 is a perfect square. Okay, so square root the cos to the 4 is going to give us cos squared and cos squared. Don't give it away yet. You're too fast. And what are the signs always in the middle? One's a plus, one's a minus. Doesn't matter which one you put first. And now we're going to square root the sine squared, which gives us, I said sine squared. Sine to the 4th, which gives us sine squared. See, I'm so excited because what do you see there? So happy. That's how a sine to the 4th and a cos to the 4th can turn into the squareds. It's just because of that lovely identity. Okay, so simplify all fractions, try to factor. Okay, now what? Could I factor this again? Now I could, but I'm not going to. And the reason I'm not going to is because you always want to keep an eye on the other side, so you always want to compare. If I factor, I'm going to lose the squareds. What do we have over here? Squared. So although I could factor this, I'm not going to because it's not going to match this side. What is on the left that is not on the right? What do we need to get out of here? Sine squared. So I'm going to keep the cos squared, and I'm going to keep the negative. I want to boot sine squared out of here. The only way I can do that is using the identity, and what can I put in its place? What is sine squared equal to? 1 minus cos squared. Again, how did I know to do that? Because I kept peeking at the other side. And I said, okay, well, what do I need off the left that's not on the right? It's the sine squared that has to go. Voted off the island. Okay, what do we do with this mess in here? Yeah, I wanted to get rid of these brackets, so I'm going to distribute the negative. So the negative times 1 and the negative times negative cos. So I'm still going to have this cos squared in the front. Negative 1 times 1, negative 1. Negative 1 times negative cos squared, positive cos squared. And if you keep your eye on the other side, you're probably like, ooh, ooh, negative 1, this looks good. What happens here? So what's x squared plus x squared? 2x squared. What's cos squared plus cos squared? 2 cos squared. Wouldn't it be qued, technically? What's a K without a Q? Or it's a Q without a U? Qued, I don't know. I don't know. So when you're doing the homework questions and you come with one with a 4 in it, you're going to look back at this example. I'm not saying it's going to work exactly like this, but this is how to get rid of exponents of 4. Last one. This is the last one I'm doing with you, and then you're on your own for a whole bunch of them. Pick a side, any side. So which one looks more complicated? Kind of equal, so pick one, 50-50 shot. Left, okay? Change the sign and cos. Done. Look for sine squared plus cos squared. Nada. Combine all fractions, so simplify fractions. How do I know the fractions are simplified? One numerator, one denominator. So I don't have a bunch of adding or fractions on fractions, can't do anything. Try to factor. There's nothing squared, so I can't factor. Okay, start working on the more complicated side. Okay, switch to the other side. Okay, so let's go to the right. Change the sign and cos. Done. Look for sine squared plus cos squared. Done. Simplify all fractions. Nada. Try to factor. Can't do it. Okay, if you're stuck, go to the other side. Left-hand side. Whoa, do you see an issue here? Okay, so the very, very last step on that list says, as a last resort, you're going to use what's called the conjugate binomial. So now when you come to one that you're stuck from the beginning, it's going to look very much like this. Conjugate binomial is what you did way back in grade 11 when you simplified radicals that had a binomial on the bottom. So something that looked like this, for example. If I said rationalize, how did we do it? Well, we multiplied by the same thing on the bottom, except we switched the sign. That's a conjugate binomial, is when you take the exact same terms and you switch the sign. So I'm going to take the bottom and I'm going to just switch the sign that's in the middle. That's called the conjugate binomial, exactly the same terms, switching the sign. Well, mathematically, I can't do that unless I can turn this into 1, because the only thing you can multiply by is 1. So in order to make this equal to 1, I'm also going to make the top 1 plus cos squared. Okay, so because all of this equals 1, that's why mathematically I can do it. And usually I can't just start multiplying by things. Are you still with me? Okay, I'm not going to multiply out the top. I'm just going to squish it together. I'm going to leave it as sine and then bracket 1 plus cos. The reason I'm not going to multiply it is because one of our steps is factoring. So if I multiply here, I'm just going to turn around 2 steps later and factor. If you forgot that and you multiply, no big deal. Just factor later on. I am going to multiply out the bottom because the conjugate binomial always changes something in here. And I like to bracket to remind myself these are binomials, and we know we have to FOIL them. So 1 times 1, 1. 1 times positive cos. In the middle, negative cos times 1. And the last 2 terms, negative cos times cos. Okay, so that was just a FOIL. Still keeping the top, still not multiplying it out. Simplify the bottom. Oh, coses cancel. Okay, so what am I left with? Okay, change the sign and cos. Done. Look for sine squared plus cos squared. Nope. Simplify all fractions. Done. Try to factor. Oh, what did we talk about 2 examples ago? Okay, so can we factor it? Okay, if we factored it, what would it look like? 1 minus cos and 1 plus cos. Hey, Mr. Radley.
How's it going?
Good. We're doing identities.
That's excellent.
I enjoy them as well.
I enjoy identities too. Like, so you just go through and you factor this, you see. Factor 1 minus cos squared theta.
Into?
Into, well, 1 plus cos theta and 1 minus cos theta.
And then?
And then you cancel the 1 plus cos theta with the 1 plus cos theta.
And children, if we did that, we would go right back to the beginning.
Look at that. Isn't that amazing? Yes.
If we chose to factor here, which is what your brain's going to want to do, we're going to go right back up to here.
Okay. Oh, so this is...
Don't.
Yep.
So occasionally you need to resist the urge to factor, and after you use the conjugate binomial, you have to resist the urge. Again, if you did factor and you canceled, you'd just be right back up here.
This is actually, science.
Let's not tell them that yet.
Oh. Something else. Okay. So,
Yeah. So resist the urge to factor after conjugate binomial.
I'm just your man on the street that... Hello, man on the street. How are you? Oh, not bad. You want any identity? Well, I can help you with this, or help you resist.
Resist the urge.
It's like drug resistance training. No. You have to say it 3 times.
Why 3?
No. What's that?
Why 3?
Well, because then bad people, well, they can't take that kind of rejection. They walk away.
Yeah, all of it. Yeah, all that was recorded. That's awesome. So again, your brain is going to want to factor, and your brain's going to want to cancel, and it's fine. It's just then you've gone right back up to here. Okay, so if we can't factor it, you always want to peek on the other side. What do I need on the bottom? So what do I need to get rid of here that's not over here? So look at your formula card. Do you see anything that says 1 minus cos squared? Oh my God. Okay, so keep the top. And 1 minus cos squared becomes sine squared. And why can I cancel here? Because I'm multiplying this side. I'm not adding it to anything. So as long as we're multiplying, we can cancel. So what's left on the top? On the bottom? And? And I'm pretty sure the original does not have an exclamation point. It just makes me so happy when we're done. This is a last resort, and you're going to know when it's conjugate binomial because there's nothing else you can do. You can use conjugate binomial in other questions, but the problem is it sometimes makes it more complicated. So sometimes you'll do it and you'll get so much stuff in there, there probably was an easier way. That's why I say it's a last resort if you can't do anything else conjugate binomial. What would we have done if we had started on the right? So let's pretend we decided this is a better side. What would we have used the conjugate binomial on? So what would we have multiplied here as our first step? We would have done 1 minus cos to match this one. Okay, so it would have worked the same way, we just would have had a different conjugate binomial here. I'm going to stop. I'm going to make you do your dance of joy. Are you ready? I will seriously keep you here until you do this dance. I don't care if it is a finger dance, you are going to dance. Are you ready? Cash. Nick. Oh, Nick's going, okay. Nice, Robley. Very good, very good. Tina, I see nothing there. What? Tina, see nothing. Jenna. I don't want to do that. I want to get rid of you. You are done with me for the first part of identities. Those are the only examples we're going to do. What you want to do in today's class is go back to that Mushu sheet. Did she tell you why I called it the Mushu sheet? Because it's got Mushu from Milan on it.